Okay, hot water is dripping through coffee maker, filling a large cup with coffee. This is the amount. So is that a rate function or an amount function? This is the amount. It is not a rate function. Important to note for the problem as we continue on. Selected values are given. Use the data in the table to approximate C prime of 3.5. What does C prime mean? Derivative. So if I want to find the rate or the derivative, I don't have a function that I can actually use. So what will I use instead? Slope formula. Yep, I'll use a slope formula. A is, so C prime of 3.5 is going to be approximately C of 4 minus C of 3 divided by 4 minus 3. What is C of 4? 12.8 minus 7.2 divided by 1.6 what? What is the measurement in? Ounces per minute. His cake upside down. Okay, let's look at B. Is there a time between 2 and 4 for which C prime is equal to 2? Let's look at the change, the rate of change, the slope between 2 and 4. Okay? Let's find out what that is. Let's do C of 4 minus C of 2 divided by 4 minus 2. What is C of 4? 12.8. What's C of 2? 8.8 divided by 2. And I get 2. 2 what? So, if the average rate of change between 2 and 4 is 2, does there have to be a time in between where the derivative is then 2? What this is asking, folks, is this question. I have a function, and I'm going to look at the average rate of change. Average rate of change is expressed by that. Is there somewhere on this curve where the derivative has to have the same slope? Yes. Do you remember what we called that theorem? Mean value theorem. Mean value theorem says if you look at the average rate of change over the entire time, then there has to be some point in between where the instantaneous rate of change is the same. So let's write that down. Thus, the mean value theorem, MVT, guarantees a value 2 less than t, which is less than 4, such that C prime of t is equal to 2. So we invoke the mean value theorem at that point. Normally, people wouldn't see that right away till we go over it, so don't feel bad about that. Okay, let's look at B. B says use a midpoint sum with 3 subintervals to approximate the value of 1/6 integral 0 to 6 c of t dt. Then we'll interpret it. So 1/6 integral 0 to 6 c of t dt. How many subintervals? 3. So if the entire interval is 6, then what's the width of each subinterval? So what is the middle of the first one? 1, and I evaluate a height of 5.3. 3, I evaluate a height of 11.2. 5, I evaluate a height of 13.8. So let's evaluate this. We've got 1 over 6 times, what's the width of the first subinterval? 2 times, what's the height? 5.3 plus 2 times 1.2 plus 2 times exactly. So you can do 1/3 then times, and we can add up the 5.3 plus 11.2 and 13.8. So that's going to make 25. So 30.3, 1/3 of 30.3 ounces. Now we got to interpret what it means. What does that thing mean? Average amount of coffee in the cup. Look at the 10.6. Does that, or 10.1, does that seem to match with about what the average would be? Yeah. So let's describe what that means. The integral from 0 to 6 of 1 over 6 c of t dt is the average number of ounces in the coffee cup from time equals 0 minutes to time equals 6 minutes. Is it minutes? If you don't include the 0 to 6, they're going to take points off. Yep. Okay. Was that letter C? So let's do D. The amount of coffee in the cup in ounces is this guy. Use this model to find the rate at which the amount of coffee in the cup is changing when t is equal to 5. I'm looking for the rate at which the amount of coffee in the cup is changing. I'm looking for that rate. How do I find a rate? Derivative. I got to take the derivative of that. So B of t is equal to 16 minus 16e to the negative 0.4 t. I got to find b prime of t. What's the derivative? So the derivative of 16 is 0. How do I find the derivative of negative 16e to the negative 0.4 t? Chain rule. So negative 16e to the u and negative 0.4 t. Derivative of negative 0.4 t. Multiply 6.4 e to the u. Whoop. I actually multiplied that together too quickly. So when you multiply the negative 0.4 times the negative 16, we get 6.4. Again, this is no calculator problem. E to the negative 0.4 t. So I got b prime of t. So now what I need is I need b prime of 5. So I will plug in 5. What's 0.4 times 5? 2. Ounces per minute. Let's check our scoring guide, see how we did. Oh boy. Did I? What year? Okay, looks like it's right here. 1.6 ounces per minute. You can see in part B here, I don't know if they would take points off for that or not, but they say C is differentiable, therefore C is continuous. I don't know if you have to make that statement or not. I would err on the side of saying if it's differentiable, therefore it is continuous, and that way you can apply the mean value theorem and the intermediate value theorem. So you get 2, says by mean value theorem is at least one time, yada yada. This one gets 10.1 ounces. It says is the average amount of coffee in the cup in ounces over the time 0 to 6. Notice you get 1 point for the midpoint sum, 1 for the approximation, 1 for the interpretation. And then here you get 1 point for finding b prime of t, which we said was 6.4 e to the negative 0.4 t, and then 1 point for plugging in the 5, and you do have to give the correct label. Anytime they give the label, you must do that in order to get the entire point. If you don't get 9 out of 9 every time, it's okay. It would be abnormal to get 9 out of 9 every single time. Okay? So, all right, let's do one together, and then we'll give you an assignment to work on. Let's try this one. If you back up one page, I think you get to this. Love this problem. This is a great problem. You're going to do great with this problem. Last hour did as well, and you're going to do a good job with it. Karen rides her bicycle along a straight road from home to school. Starting at time 0, she's at home. So she's home here. She's at school here. Okay. During the time interval from 0 to 12, her velocity is modeled by this function. So we have a v of t function. So this is a rate function. The last one was an amount function, not a rate function. Okay. So it says find the acceleration of Karen's bicycle at 7.5 minutes. What does this mean? Yeah, so a of t is equal to v prime of t. They love it when you make that kind of a statement. Well, it's just a line. How do we find the slope of a line? Yeah, you just do rise over run. So we got v of 8 minus v of 7 over 8 minus 7. Yep. What's v of 8? What's v of 7? Divided by 8 minus 7. There we go. Go get your brain food. Come on back. Be ready to go. Okay, so sorry about the break, but I think that my ideas are hilarious. YouTube Nation, we're talking about things to do for our TV station, The Growl, and I've got some haters in the crowd that don't like my ideas. So Wally likes my ideas. Go Wally. All right. Maddie likes my ideas. We got negative 0.1 what? Is it miles or? Okay, so is she accelerating or decelerating? She's decelerating, okay? And you can see here that she's trending down, so therefore you know that her velocity is decreasing, so she's decelerating. Looks like we answered that one. Indicate units of measure. B says using correct units, determine what that means. And we're going to find that value. So B says the integral from 0 to 12 of the absolute value of v of t dt. What the heck does that mean? Yes. Is the total distance in what? Measured in? Oh, acceleration. Thank you. Total distance in miles. Karen has traveled from time equals 0 to time is equal to 12. Yes, they want to see the 0 to 12 and what those numbers represent. Okay? I agree. And Kelsey, I'm right there with you. You know, to say from home to school. But what they have to do is they have to find a clear way in which everybody will judge these consistently. And so as opposed to some people saying, well, that's good enough, and other people saying, we need the 0 to 12, they say everybody just wants 0 to 12. Now we have to calculate that. So the integral from 0 to 12 of v of t dt, absolute value, I got to calculate that. Sweet. Well, so I take the absolute value of all of this, right? So everything's positive. So what does that mean? What am I trying to find? What am I going to do with this? What? Caleb, say it like you mean it. Add what up? What am I adding? The area. Okay, you're doing the integral. That means I want to know all of this. And I want to count it all as positive because it's the absolute value. No, this is a, or yeah, you can if you want. We don't really need to. So, so let's take a look at this guy. This is 1/2 times the base, which is 2. What's the height? I'm finding the area of this triangle. 0.2. So if I multiply that, I get 0.2. There's the same amount underneath, but it's negative. Why is this positive and then this negative? She's going back. Here she's traveling to the right to school, and here she's traveling back towards home. She forgot something probably. Yeah. Yeah, if you read on the problem, you find out she left her calc homework at home, so she had to turn around. So she's got 0.2 there, and she's got 0.2 there. And we're counting it as positive because, again, it's total distance. And now, how much is each one of these boxes? 0.1. So we got 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So plus 1.1. These last two, if we do base times height, so and divide by 2, so base is 1 times height is 0.2, and then divide by 2, I get 0.1. And then how about here? Base times height would be 0.3, and then divide by 2 would be 0.15. And then this is half of 1, right? Which is 0.05. So I get 0.2, 0.2 is 0.4, so 1.6 if we add all those up, and then plus 0.2, which is 1.8. So 1.8 what? Sweet. So that's B. C, one of my favorite parts of this AP stuff. Shortly after leaving home, Karen realized that she left her calculus homework at home. Oh no. That's when you use your oops. Got it. What? Yeah. So I mean. Oh no. All right. So let's figure this out here. At what time does she turn around and go home? She goes home at time 2. Why? Velocity changes from positive to negative. Karen turns home at time equals 2 minutes. At 2 minutes, her velocity changes from positive to negative. Now, again, I have not been one of the AP graders. I would like to do that at some point in my life. But I will tell you right now that from everything I've heard, they really want to stress that you understand that it changes from positive to negative. Okay? What's that? You know, I haven't even applied to do it just because right now summers are so important to me. I want to be home with my children. but it's more important for me to be a good husband and a good father than it is for me to be a good teacher. But someday the kids will be out of the house, and when they are, I might try to take some summers and grade some of the AP stuff. I think that'll be good. Yes, you do get paid well. So you go out to like Colorado or to Idaho or somewhere out west. So yes, yes. Yeah, it's in Vegas. All right, here we go. Part D. All right, it says Larry also rides his bicycle along a straight road from home to school in 12 minutes. His velocity is modeled by this function. So he has a velocity function as well from 0 to 12. Who lives closer, Karen or Larry? Well, let's find Larry's distance. If I want to find the entire distance that Larry traveled, what would that look like? 0 to 12 of WT dt. Now, that's assuming that he doesn't turn around at some point. The problem doesn't state that he turns around anytime. We should really look at the function. I've typed it in. I've got pi over 15 times sine of pi over 12x. And if I go to my window, I'm going from -2 to 14. That should help me see from 0 to 12. And my y minimum, pi over 15, that's going to be like 0.2 or something. So I'll just go -0.4 to +0.4. And we should hopefully see a really good graph here. And so does he ever cross from positive to negative for his velocity? Yeah, at 12, right? So between 0 to 12, he doesn't. So true or false? The integral of w of t would be the same as the integral of the absolute value of w of t. It would from 0 to 12. So I think we could just leave it like this and count that as good. And so I'm going to go second calculate and do number 7 from 0 to 12. Is it? It just, that never gets old. It's always like, yay, fun. All right, 1.6. And then we have Karen. Yeah, when you see the answer, I think that they would give us full credit for ours, but I just did the integral instead of 0 to 12. I did 5 to 12. And then what I did is I took, what's her entire distance? What was her distance we came up with? 1.8, and what would we subtract off? We'd subtract off this amount and that amount, right? Because, that's double of what she really traveled. So I'd subtract off 0.4, and I get 1.4 miles. Karen lives closer to school. So let's check that answer. What year? Number 1. Oldie but a goldie. So let's look and see what we've got. The first one, if you just do that acceleration piece, you could get yourself 2 points just for having the answer in the unit. So that's a 2 out of 9. It's a lot better than a 0 out of 9. Explaining that this is the total distance traveled from 0 to 12, you get yourself a point just for that. So 3 out of 9, I think, are very reasonable for everybody to be able to come up with here. The value of the integral 1.8 is another problem, or another point. C, they give you 1 for the answer, so at time equals 2. And I think most everybody could have picked that up as well. So a lot of points you could get on this one. Justifying it by changing from positive to negative gets you a point. The last problem, they give you 3. 2 points for Larry's distance. Number 1, coming up with the integral from 0 to 12 to WT dt. And then if you get the 1.6, that gives you your second point. And then Karen's distance, they just do from 0 to 12 of v of t dt, or the displacement. I guess displacement, that does make sense, doesn't it? I'm just saying, I don't know, you know, if we said 5 to 12, would they mark that off? Yeah, okay, good point. So the scoring guide says Karen's distance from the school and the conclusion. So coming up with the 1.4 and Karen lives closer. So however you came up with the 1.4, they don't really care. They're just saying that this is one option. They chose to use displacement, which works out the same. Okay. Got it. So there you go. So you want to try some problems because you want to be excellent at the AP exam, and I really applaud you for that. So your first packet, you know, you can put that back into your binder. We won't get that. We won't go back to that probably again. But this one right here, what I want you to do is on a separate sheet of paper, I want you to do problems 7 and 8. So you have two homework sections right now. Your first homework problems were to do numbers 4 and 6 from the first packet. And now you have to do problems 7 and 8 from this packet. So, and I think that the past couple days are some of the most challenging problems that you'll see for the free response. Tomorrow we're going to start looking at area and volume, which is what you just took your test on. And so it will be much more familiar to you. And I think you'll do quite well with it. Okay? All right.